Hello students, my name is Sumit Mehta. So in today's lecture, we will discuss some properties of inverse trigonometric functions, or we will discuss formulas of inverse trigonometric functions that we will be using in further lectures. Okay, so I am writing down all the formulas. So students, the first formula is sine inverse of 1 by x is equals to cosecant inverse x, where h should be greater than equal 1 and or h should be less than equal minus 1. Okay, if so, sine inverse 1 by x converted to cosecant inverse 1 by x. Now the second formula is similar to sine inverse 1 by x, it is cos inverse 1 by x is equal secant inverse x, and the condition is same. X should be lies between, it should be either greater than 1 or it should be either less than minus 1. And the same formula again for tan inverse 1 by x is cot inverse 1x, and condition is x should be greater than 0. So all these formulas are of same type. Okay, so now we will discuss different formulas which are odd functions based formula or odd or even functions based. So sine inverse minus x is equals to minus sine inverse x for all x belongs to minus 1 to 1. Okay, so this is 2a, let's say. So this is 1 1 to 3. Now this is b formula is tan inverse minus x is equals to minus tan inverse x, where x belongs to real numbers. And c formula cosecant inverse minus x is minus cosecant inverse x. Okay, and mod x should be greater than 1. Now students, similarly we can choose for cos inverse minus x is pi minus cos inverse x, where x lies between minus 1 to 1. Okay, now the e part is secant inverse minus x. So this is minus x, student. Pi minus secant inverse x, where x mod belongs to greater than 0. F part is cot inverse minus x is pi minus cot inverse x, and x belongs to R. So these three functions are of similar nature and these three are of similar nature. Okay students, now let's discuss some more properties based on inverse trigonometric relations. So students, here the next property is sine inverse minus x plus cos inverse minus x is equals to pi by 2 for x belongs to minus 1 to 1. This is a part. Now b part is tan inverse minus x plus cot inverse minus x is pi by 2 and x belongs to all real numbers. C part, student, cosecant inverse. Students, you can test these results by using the graphs which we have plotted in earlier lectures on inverse trigonometry. Okay, so you can verify all these results using those graphs also. Okay, so these are the similar type of formulas. Okay, now let's discuss some more formulas on, let's say this is a fourth type. First formula is tan inverse minus x, tan inverse x plus tan inverse y equal tan inverse x plus y upon 1 minus xy, where xy less than 1. Second part, here it is my negative sign. Tan inverse x minus tan inverse y is equals to tan inverse x minus 1. So this is the formula somewhat related to each other. Okay, now let's discuss three more formulas and then we are done with these properties. So the formula of fifth type is 2 tan inverse x in terms of sine is sine inverse 2x upon 1 plus x square. So mod x is less than equal 1 in that case. So this 2 tan inverse x again in terms of cos inverse x, it is 1 minus x square upon 1 plus x square, where x should be greater than equal 0. And this same 2 tan inverse x in terms of tan itself is tan inverse 2x upon 1 minus x square, where x should lie between 1 to minus 1 in open intervals. Okay, so student, these are all the properties or formulas that we will be using in next lecture on questions based on inverse trigonometric uh, properties. Okay, so these are very important formulas from exam point of view also, and you should make a note of it on a very fair paper, and you should paste this paper on your above your study table. Okay, so that you can learn on daily basis. Okay students, so by in the next lecture we will discuss about some questions on properties of inverse trigonometric functions. So stay tuned for that lecture. Thank you, happy learning.